Solving an absolute value equation. In other types of equations, we touched on the concepts of absolute value equations. Now that we understand a little more about their graphs, we can take another look at these types of equations. Now that we can graph an absolute value function, we will learn how to solve an absolute value equation. To solve an equation such as 8, which is equal to the absolute value of 2x minus 6, we notice that the absolute value will be equal to 8 if the quantity inside the absolute value is positive 8 or negative 8. This leads to two different equations we can solve independently. Now recall that we had a definition that the absolute value of x, which is equal to a, where x is the expression, tells us that x is equal to negative a or x is equal to positive a. So for example, if we had the absolute value of 2x minus 6, which is equal to 8, which is what this example is, we can apply the definition. The definition means that you need to remove the absolute value and create two equations, where we have 2x minus 6, which is equal to negative 8, or 2x minus 6, which is equal to positive 8. And then we're going to solve for x on both sides. So we add 6 to both sides, we get 2x, which is equal to negative 2. Divide both sides by 2, and then x is equal to negative 1. On the right side, we're going to add 6 to both sides, we get 14 on the right. Divide both sides by 2, and x is equal to 7. So we have two solutions, negative 1 and 7. Now, knowing how to solve problems involving absolute value functions is useful. For example, we may need to identify numbers or points on a line that are at a specified distance from a given reference point. An absolute value equation is an equation in which the unknown variable appears in the absolute value bars. So for example, we have the absolute value of x, which is equal to 4. The expression is x. Here we have the absolute value of 2x minus 1 equals 3. The absolute value is 2x minus 1. Over here we have the absolute value of 5x plus 2 minus 4 equals 9. In this scenario, we would need to isolate the absolute value before we can apply the definition. We would have to add 4 to both sides, where the previous two, it's already isolated on the left-hand side. Now, solutions to absolute value equations. For real numbers a and b, an equation of the form the absolute value of a is equal to b, with b being greater than or equal to 0, will have solutions when a is equal to positive b or a is equal to negative b. Now, if b is less than or equal to 0, then the equation absolute value of a is equal to b has no solution. So let's take a look at this scenario and why would that be. So if we had the absolute value of, let's say, x plus 2, okay, and that's equal to negative 5. So negative 5 is a number that's less than 0. Now, the question you need to ask yourself is it possible to take an absolute value of an expression and get a negative number? No. And because of no, then this would be no solution. Okay, now going back to our third scenario, if we had, again, the absolute value of x plus 2, and let's say this is plus 7, and then this is equal to 3. Right now, so far it applies. But recall that we always want to isolate the absolute value. In order to isolate the absolute value on one side of the equation, we need to subtract 7 to both sides. And here we would get negative 4. Now again, we get an absolute value that's equal to a negative number, and now at this point, this would be no solution.